going to have a little look at question 7 from your November assessment paper. Okay, please notice that you're told you can use a scientific or graphical calculator, and you're permitted to use that in this paper. Okay, so it's been put on 2 bullet points to emphasize you can use your calculator. Right, we're going to have a little look at number 7. So this question said show detailed reasoning. Now that means that you can't only use your calculator and copy your answer down. You have to justify what you're writing or drawing. Okay, so the first part is sketch y equals 2x squared minus x minus 3. Okay, so here are some different responses that I've been marking. So this is, several people did something like this. They sensibly tried to find some roots. So they set y equal to 0, they factorised the expression, and they found 2 roots. So that works for detailed reasoning. That justifies their choice of -1 and 1.5 on the x-axis. Okay, and then we can take it as read. So if you substitute 0 in, you're going to get -3 on the y-axis. So when you're asked for a sketch, you need to put where your graph crosses the x and y axes. However, this question doesn't get all of the marks, so this answer, sorry, doesn't get all of the marks because it looks like the minimum is at -3. But if this person had chosen to use their calculator, they would have discovered it's not at -3. Alright, here's a different response. So this person has used their calculator, but I've got the graph on here. I'm going to do zoom, okay, auto, and we'll see what happens. So it looks like what they've done is approximately copy the zoomed version, the auto-zoomed version of the graph. Now, as we know, it's tricky to get the axes correct when you're sketching graphs. But this one, it's really hard to see what's going on. All of the interesting bits are going to be down here near where x and y are both 0. So it'd be much better to either zoom and use a little box around it. So you can do, for example, box. So I'm going to move my little mouse cursor. Okay, kind of, let's go about there. You press execute and then you move across and you move down. Okay, execute. There we go. That's better already. Or you could have used view window and initial conditions, or view window and standard, and it would have helped for this one. Right, so what this person hasn't done is they haven't used gsolve. Okay. However, this person obviously did, which is super. So this person has done gsolve and root, and that tells them that it crosses the x-axis at -1 and at 1.5, and they've marked it on. We could do gsolve and y-intercept, or work it out for yourself. Y is -3, and gsolve and minimum. Okay, and so we get the minimum point there, which is brilliant. Now the only problem is with this question that without any factorising to justify the choice of roots, okay, then they don't get the detailed reasoning marks. All right, that's the only thing you'd require though, is the factorise to get the roots, because that automatically tells you where the minimum is, which quadrant it's in, because there's a line of symmetry. So the minimum has to be on the line of symmetry, which is exactly halfway between -1 and 1.5. Lots of people did though complete the square to get this minimum point, which is super. Okay, and that's another way of doing it, but it saves you some bother if you just get the roots and you want halfway between. Okay, right, now the next part of the question, part B, says hence or otherwise solve this inequality. So what you would normally do is you'd start with this, you'd factorise it, get the roots, or use your calculator to solve and get the roots, and then you do a little sketch, and then you'd see which bit was less than 0. So it seems silly to start from scratch. It seems sensible to use the hence. You've already got the graph. You already know what the roots are. So you're just thinking, I need the bit where the graph is below the x-axis, okay, because y is less than 0, and so you just want this range of values in here. So x is between -1 and 1.5, or nicer as fractions. Okay, so that was B. So your answer from A is helping you with B, saving you a lot of time and effort. Okay, let's have a look at C. Okay, given that, and look, it looks exactly the same as our graph, 2x squared minus x minus 3 equals k, has no real roots. Find the set of possible values for k. So lots of people very sensibly thought, right, this is a quadratic. If I make it equal to 0, I can look at the discriminant, which has to be less than 0, and solve it for k. That's great. Okay, that works well as long as you have subtracted k to make the whole thing equal 0 first. Otherwise, disaster. Okay, however, you can save yourself some effort by looking at the graph. Okay, so if we've got y equals 2x squared minus x minus 3, and we're looking at when this thing is equal to k, so we've already got this graph, so if we look at the graph of y equals k, and we want to see where these two graphs intersect. Okay, well y equals k, y equals a constant, is just a horizontal line. So my pen is going to be my nice y equals k line. So I can see here that for this horizontal line, I've got 2 points of intersection, so I've got two solutions, 2 roots. But if I move it down, and I get to exactly the minimum point, I've only got one solution now, it's a tangent there, it's got one solution at the minimum point. And if I let y equals k, if k is a smaller value than the minimum value, okay, then I'm going to have absolutely no solutions. This horizontal line does not intersect the curve. Okay, so your graph again can help you solve that equation without loads of algebra. Alright, so as long as k is less than the minimum value on the graph, so minus 3.125, then there will be no real roots to this equation. Okay, now because it says show detailed reasoning, you still have to do some justification, so you'd have to show how you get that minimum point. So in that case you could either complete the square, or you could use your symmetry line to get the x coordinate is 0.25 and substitute in to get the y coordinate. Or you could differentiate 2x squared minus x minus 3, set it equal to 0 and solve for x and substitute in for y. Or you can use the discriminant method that I just mentioned earlier. So lots of options for the last part, for C, okay, but the graph can help you speed things up.